All right, here we go. This is problem number 12 out of chapter 5, the Halliday and Resnick textbook. I like this problem, largely just because it's got graphs. It seems like a common thing on these sorts of tests is to have graphs. So we've got two horizontal forces acting on a 4-kilogram disc that slides over frictionless ice on which an XY coordinate system is laid out. So you've got, your ice, here's your hockey puck or whatever it is. It doesn't say it's a puck, it says it's a disc. And that would be a very heavy hockey puck, I guess. So anyway, the mass of our object is 4 kilograms. Again, I'm being sloppy about significant digits because we're more worried about the concepts here. So we know that force 1 acts in the direction of the positive x-axis and has a magnitude of 7.0 newtons. So that's this, 7.0 I newtons, right? Force 2, we don't know the direction of it, but we know it has a magnitude of 9 newtons. It's a decimal there. Now, the graph at the right gives the x component. This is huge. It's the x component of the velocity as a function of time. All right, so what we want to do is we want to find the angle between F1 and F2. So in other words, here's the disk, right? Here's F1. We know that this guy is 7 newtons. And then F2, so there's our F2. But the problem is we don't know what direction it's going in, so well, that didn't work out the way I wanted it to. But anyway, my point is we don't know what direction F2 is going in, right? And so that's kind of what we're trying to find. So let's look at this graph and see what we can get from this. The graph tells me that at time 0, the horizontal velocity is -4 meters a second. And by reading the graph, I can see that after 2 seconds, the horizontal velocity is 2, or after 3 seconds, the horizontal velocity is 5. Take your pick. I'm going to use this point just because, I don't know, because I am. All right, so I know that if my time is 3 seconds, then I get a horizontal velocity of 5 meters a second. And so use your acceleration equation. A equals v minus v naught over t. But for us to be specific, this is all horizontal, right? So I just switched my OX and my XO. All right, so anyway, you get 5 meters a second minus -4 meters a second over 3 seconds. So we're going to get 3 meters per second squared. So what that represents is the acceleration in the x direction of the particle. So, awesome. If I have not emphasized it enough, everything that we just found here in blue that I'm shrinking right now is in reference to the horizontal motion of the object. So I just found an acceleration. Awesome. So find your net force. Net force is mass times acceleration, right? But the problem is, this is an acceleration, it's not the acceleration. That is the horizontal acceleration. So, multiplying that by the mass will give me the horizontal net force. In other words, the sum of the horizontal components of all of the forces. So, my mass was, what, 4 kilograms? My acceleration we just found is 3 meters a second squared. Multiplied out, you get 12 newtons. Aha! We are making some progress here. So what that means is that the x components of my forces have got to add up to 12. Well, look, the x component of F1 is just 7, right? So that means that 7 newtons plus the x component of F2 have got to add up to 12 newtons, right? So the x component of F2 has got to be 5 newtons. Haha, we are making progress. So let's draw F2. Here's what I know. I know F2 is going to point at some angle. I don't know if it goes up-ish or down-ish, and it doesn't really matter. So let's arbitrarily assume that it points up-ish, okay? So what we know is that F2 is 9 newtons. We know that the horizontal component of F2 is 5 newtons. So we can find this angle, right? I guess I could draw in my y component. So we can find this angle here. It turns out to be 56 degrees. So, and that's actually the answer that we're looking for. Sorry, maybe I glossed over that. That angle, I just used a little bit of trig, right? We know our adjacent component. We know our hypotenuse, so you can use what, cosine, inverse cosine to find that angle. Yes. So why is that the answer? Well, the idea is that I don't have any room on my board here. Making this way more complicated than I need to here. So remember, F2 points at some angle, and we assumed arbitrarily that it's pointing upward, right? And we're looking for the angle between F2 and F1. Well, remember, F1 is horizontal, right? So the direction of F1 is the same as the direction of F2x, right? And so when we found this 56 degrees between F2 and the horizontal component, that's the same as finding the angle between F2 and this horizontal vector, F1. There we go. All right.